Solving quadratic equations, the factoring method. Our learning goal today is to use factoring to solve quadratic equations. Please ensure you have the lesson printout so you can follow along with this video. Recall solving linear equations. Do you guys remember how to solve this? That's right, we'll move all our variable terms to one side and all our constant terms to the other. So we'll move the 2x over to the other side. So we'll get 3x minus 2x minus 6 is equal to 4. And then we're going to move minus 6 over to this side. So we're going to get, I'll just move this up here. We're going to get 4 plus 6 is equal to 3x minus 2x. And we can just simplify this. 4 plus 6 is 10. And then 3x minus 2x, that's equal to 1x. So x in this case is equal to 1. But what happens if it is nonlinear, meaning x has an exponent other than 1? Quadratics are a good example of this. Let's take a look at the equation x squared plus 4x minus 10 is equal to 0. How do we solve a quadratic? To solve a quadratic equation means finding the values of the variable that makes the equation true. Recall left side is equal to right side. So that's what we're going to do. And so there are several methods of solving quadratics, and some of them you already know. So let's go through those. The first method that we will take a look at for solving quadratics is the factoring method. When using the factoring method, our equation is usually in factored form. As you recall, the factored form of a quadratic looks like this. Y is equal to a bracket x minus s bracket x minus t. We will then look at the square root method, which is usually in vertex form. And finally, we're going to look at the quadratic formula method, which is usually in standard form. Let's take a look at method number 1, solving quadratics by factoring. When your quadratic is in the standard form, it is easiest to first check if you can solve by factoring. So our factoring means our first bracket times our second bracket equals 0. And a product only equals 0 if one or both of the factors equal 0. So these are our factors, and either the first bracket must equal 0 or the second bracket must equal 0. Okay, so this is only true if m is equal to 0 or n is equal to 0. We can move all the equations to one side and set it equal to 0. Then we can form mini equations to solve. Let's try some examples together. We will now go through the steps of solving one of these problems. What you'll notice is that a lot of this will be review for you, but no worries, it's a good opportunity to practice your factoring skills. Number 1, proper format. All parts of equation are on one side and it is set equal to 0. So here we have our equation here, x squared is equal to negative 7x minus 10. So what we want to do is be a little bit strategic. I don't like working with negative numbers, so I'm going to move these two terms over to this side. When we do that, the terms signs are going to switch. So we're going to get x squared plus 7x plus 10. And because we moved everything to one side, remaining on the right-hand side will be 0. Number 2, factor. So this is just the same factoring that we've been doing before. We want to think of two numbers that equals to a times c, which is, in this case, a times c is going to be 10, and add up to b, and that would be 7. Can you think of two numbers that add up to 7, but multiply to 10? That's right, 5 and 2. Okay. Because this is a simple trinomial, we can go straight to our factor brackets. We don't have to do decomposition or anything like that. So we have x plus 5 and x plus 2 is equal to 0. Number 3, let each factor equal 0, the mini equations, and solve for x. So we have our two factors here. We have x plus 5. We're going to make that equal to 0. And on the other one, we have x plus 2, and we're going to make that equal to 0. And we just have to solve for x. So we're going to move the 5 over to the other side. So we're going to get x is equal to negative 5. And on this one here, we're going to move the 2 to the other side. We're going to get x is equal to negative 2. And this is our solution. So we can say solutions for x squared plus 7x plus 10 are x is equal to negative 5 and x is equal to negative 2. So the good thing about using the factoring method is that it's quick and easy as long as you know how to factor. The bad thing about this method is that not all equations will be factorable. But in our later lessons, we're going to learn a technique that will help us solve any equation, even if it's not factorable. Try some more examples. Let's solve for x for the following. Sometimes it's easy if it's already factored. So here we have our factor brackets. We're just going to set each to 0 and solve for x. Okay, and then we'll move the 4 over to this side, so x is equal to negative 4. And then we'll move the negative 3 to this side, so x is equal to 3. So those are our solutions. X is equal to negative 4, and x is equal to 3. Let's try this one over here. We have 2x minus 1. We'll make that one equal 0, and then we have 3x plus 1 is equal to 0. In this case, we're going to move the 1 over to the other side, so we're going to get 2x is equal to positive 1. And then we want to get x by itself, so we'll divide both sides by 2. These will cancel, and so we'll get x is equal to 1/2. In this case, we'll have to move the 1 over to the other side. We're going to get 3x is equal to negative 1. We'll divide both sides by 3. These 3's will cancel, and we'll get x is equal to negative 1/3. These are our solutions. Let's do example C. Here, we have a couple of factor brackets. Negative 2x is equal to 0, and x minus 3 is equal to 0. This one is easy to do. We just divide both sides by negative 2, and these are going to cancel. We're going to get x is equal to 0. In this one here, we'll have to move the 3 over to the other side, and we'll get x is equal to positive 3. And these are our solutions. Sometimes it is not factored, so you must factor it first prior to solving. Example, solve for x in the following. Okay, here it's already set up on one side, so we have to think of two numbers that multiply to a times c. In this case, a times c is equal to 14, and add up to b, and in this case, b is equal to 9. Can you think of two numbers that multiply to 14 and add up to 9? Because this is a simple trinomial, we can go straight to the end if you know those numbers. That's going to be 7 and 2. So we can go straight to our factor brackets. X plus 7, x plus 2. And now we just need to solve. So we have x plus 7 is equal to 0, and x plus 2 is equal to 0. So let's move the 7 over to the other side here. So x will be equal to negative 7. And when we move the 2 over, we'll get x is equal to negative 2. And these are our solutions. Let's try B. Here, there's not much we can factor, although we can factor an x from both of these. So we can, if we factored out an x, we'd be left with negative 2x plus 5 equal to 0. And so we're just going to set our factors to 0. So we have x is equal to 0. That's 1. So you don't have to do anything there. And our next one is going to be negative 2x plus 5 is equal to 0. So we just want to solve for this one. So we're going to move the 5 over to the other side. So we're going to get negative 2x is equal to negative 5. And then we want to divide both sides by negative 2 to get our x by itself. So these will cancel, and we'll get x is equal to negative. So negative divided by negative is positive 5 over 2. And we can just leave it like that. So those are our factors. Let's try C. Can we think of numbers that multiply to a times c, which equals negative 7, but add up to b, which is negative 4? So let's go through our factors here. If you don't know them, we know we have 1 and 7, and then 7 and 1. Even if this was negative, or this was negative, or the other way around, we wouldn't be able to factor this one. So this one, for now, we will say cannot factor. In the future, we'll be able to solve this using a different technique. So let's practice. Let's solve for x by factoring if possible. Okay, so here we have our equation, x squared plus 7x minus 8 is equal to 0. So we have to find two numbers that multiply to a times c. In this case, a times c is 1 times negative 8, which is negative 8. But add up to b, in this case, b is 7. Can you think of two numbers that multiply to negative 8, but add up to 7? One of the clues is that our c value, or a times c, is negative. So one of our numbers will have to be negative, and one of them positive. Okay? If you can't figure it out, you could use the t-chart like we did last time. We're going to do negative 8 and just go through all of them. But if you can figure it out, you could just jump to that. In this case, because it's a simple trinomial, and if we could think of them, we can jump straight to that part. So those two numbers are going to be x plus 8 and x minus 1. So we know 8 times 1 is negative 8, but 8 plus negative 1 is positive 7. Okay, and then we just have to set each factor bracket to 0, and then solve for x. So x is equal to negative 8 when we move it over. In this case, x is equal to 1. These are the solutions. Let's try B. So here we have 2x squared plus 13x is equal to negative 15. So the first thing we need to do is move everything to one side. So let's move this 15 over to this side. And when it jumps over the equal sign, it becomes positive. And that means there's nothing left on our right-hand side over here. So it's equal to 0. Now we have to do a times c, which is 2 times 15, which is positive 30, and adds up to b. In this case, b is equal to 13. Two numbers that multiply to 30 but add up to 13. If you can't figure it out, we can use our method here, the t-chart, and think of all the factors and then add them up to see which ones add up to 13. So let's think of all the factors that multiply to 30. We have 1 and 30. We have 2 and 15. We have 3 and 10. We have, not 4, we have 5 and 6. And then we'd have 6 and 5, so they would repeat again. So do any of these add up to 13? Right over here, 3 and 10. So now we can do our decomposition. If you guys remember that, we're going to put the 10x here and the 3x here. And let's solve for this. So we can factor these two here. Let's bring back memories, right? So we're going to get 2x out here from these two, and we'll be left with x plus 5. And then from these two, we could factor out a positive 3, and we'll be left with x plus 5. And then we're just going to factor by grouping here. So we're going to have 2x plus 3 for one of our brackets, and then x plus 5 for our other bracket. Now we just need to set each factor bracket to 0. And solve for x. Let's do this one first. We'll move the 3 over to the other side. So we'll get 2x is equal to negative 3. And then we'll divide both sides by 2. These will cancel. So we're going to get a factor here. I'll just rewrite it small here. X is equal to negative 3 over 2. That's one of my solutions. And then this one here, if we move the 5 over to the other side, we have x is equal to minus 5. And this is my other solution over here. Let's try example C. The first thing we're going to do is move everything to one side. So let's move this over here. So we have x squared. When it jumps to the equal sign, we're going to get negative 5x is equal to 0. The next thing we're going to do is factor. We can see x is common in both of these. So let's take that out. We'll bring it to the front. And we'll have x minus 5 is equal to 0. So now we're going to look at both of our factor brackets. We have one is x is equal to 0, or x minus 5 is equal to 0. And we'll just move this over to the other side. X is equal to positive 5. And those are our solutions. So let's try example D here. The first thing we'll do is we'll move this 15 over to the other side because it's on the wrong side here. So we'll get 6x squared minus x, and when we move it over, it becomes negative 15. This is equal to 0. And now we have to see if we can factor this. We know a times c is going to be 6 times negative 15, which is negative 90. And b, so our two numbers have to add up to b, which is negative 1. So two numbers that multiply to negative 90, but add up to negative 1. So if you can't think of it right away, we can go through all our multiples of 90. So we'll start here. And we'll just start from 90 and divide out 1. So 90 and 1. We'll do 2 and 45. 3 and 30. 90 can't be divided by 4 evenly, so we'll skip that one. 5 and 18. 6 and 15. And then 9 and 10. So one other clue, we can see that when we add them up, it is still a negative number. So these bigger numbers are going to be the ones that are going to be negative when we add them together here. So we know we need one positive and one negative to get a negative a times c. And we know that the bigger number is going to be the negative. So we'll put the negative here, and let's see if any of these add up to negative 1 right over here. So once we have our two numbers, we're just going to go through decomposition like we've done before. So let's go ahead and do that. We have 6x squared. We're going to break this number up into those two numbers. We have plus 9x and negative 10x. And negative 15 is equal to 0. So we're going to factor these two and then these two over here. From the first two, we could factor out a 3x, and that's going to leave us with a 2x plus 3. And we want to get the same factor in this bracket. And so out of both of these, we can factor out a negative 5, and that leaves us with a 2x plus 3 over here. And then that's how we have our two factors. And now we'll factor by grouping. So we're going to get 2x plus 3 for one of ours, and the other one's going to be 3x minus 5. Now we just want to set each of these brackets to 0. So 2x plus 3 is equal to 0. And then 3x minus 5 is equal to 0. And we just want to solve for each one. So we'll move the 3 over to the other side here. So we're going to get 2x is equal to negative 3. And then we'll divide both sides by 2. This is going to cancel. We're going to get x is equal to negative 3 over 2. Let's try this one over here. We're going to move the 5 over to the other side. We're going to get 3x is equal to positive 5. Divide both sides by 3. And we're going to get x is equal to 5 over 3. And those are our solutions. Let's look at example E here. We have 2x squared plus 18. The most we can do here is factor out a 2, a common factoring. We'll get x squared plus 9 is equal to 0. But we can't go any further than this. It's not a difference of squares or anything like that. So we can't factor this anymore. Had this been a negative 9, we've been able to factor it, but because it isn't, we can't factor this. So cannot factor. Let's try our last example here, G, for these regular type of questions, and then we'll move on to a word problem. So this here looks interesting. If you're ever given a situation like this, this looks factorable. That's actually a difference of squares. But before we attack it that way, let's see if there's anything else we can do to solve it. Okay, so the first thing I'm going to do is let's rainbow everything in. So we have 3x times x, that's going to be 3x squared plus 6x. And if we rainbow it in this side, we'll get 2x squared minus 8. Now we can move everything to one side and collect like terms. So let's do that. So we have 3x squared minus 2x plus 8. So I just move these two over to this side here. Plus 6x is equal to 0. And let's just collect like terms. We have 3x minus 2x, which is just x squared. We have remember, do that technique where we can we kind of label each of our terms. And so we have x squared. We just added these two together. We'll put it in order. 6x and then plus 8 is equal to 0. So when we simplify, we'll get something like this. And this looks factorable. So it's a simple trinomial. So we want to find two numbers that multiply to a times c. So in this case, a times c is equal to 8, and add up to b, which is, in this case, 6. So two numbers that multiply to 8, but add up to 6. I could think of those already. X plus 2 and x plus 4. Okay, and then we'll set each of these to 0, and we'll solve for x. X is equal to negative 2, x is equal to negative 4. So let's try a word problem using this technique. The user's manual for Zaid's model rocket says that the equation h is equal to negative 5t squared plus 40t models the approximate height h in meters of the rocket after t seconds. When will Zaid's rocket reach a height of 60 meters? Okay, so we have this equation, h is equal to negative 5t squared plus 40t, and this is supposed to model Zaid's rocket flight. Okay, we know it opens downward because a is negative, and we can imagine over time Zaid's rocket is going to fly up and come down like this. So what are the values of t? What is t when h is equal to 60? So this is what the question is asking. Solve for t when h is equal to 60. So let's set this up. We're going to set h to 60. And this is different from the other questions. It's not asking us for maximum or minimum. We just want to figure it out when it's 60. So this is different from what we've done in our previous units. So the first thing we want to do is we want to move this 60 over to the other side here. So we have everything on one side. So we'll have 0 is equal to negative 5t squared plus 40t minus 60. Okay, we moved it over to the other side, it became negative. Now, we want to factor this. But the first thing you may notice is that we have -5, 40, and -60. And these are all factorable by 5. So we can do common factoring first. So let's actually factor out a -5 from all of these. We'll be left with t squared minus 8t plus 12. And now all we have to do is factor this bracket on the inside here. Okay, so we want to figure out two numbers that multiply 8 times c, which is 1 times 12, which is 12. So multiply to positive 12, but add up to b, which is -8. Because it has to multiply to a positive 12, 8 times c, we know our two numbers are going to both be negative. Okay, because it has to add up to -8. So let's go ahead and do that. Can you think of two numbers that multiply to positive 12 and add up to -8? That's right. T minus 6 and t minus 2. So -6 times -2 is positive 12, and -6 plus -2 is -8. Okay, so now we just have to set our factor brackets to 0. So t minus 6 is equal to 0, and t minus 2 is equal to 0. And so we can figure out what our times are. And if we move the t over, so t is equal to 6, or t is equal to 2. And so here we have two solutions, t is equal to 6 and t is equal to 2. And this makes sense because let's say we have a rocket here flying in this trajectory, following the parabola. This is time and this is height. As it goes up, it's going to pass 60 meters, and as it comes down, it's going to pass 60 meters, right? Our heights, and we know that's going to occur when at 2 seconds, it's going to be at 60, and then when it's coming back down, it's going to be at 6 seconds. So that's basically what we solved here. So to answer this, when will Zaid's rocket reach a height of 60 meters? Zaid's rocket will reach 60 meters at 2 seconds and 6 seconds after launch. And that's all we have here for today. So why don't you try some of the homework out? If you have any problems, please just message me and practice your factoring.